Hi grade 10s, I'm now going through Earth's magnetic field and how a compass works with the Earth's magnetic field. We will be working with the Solutions for All textbook. We're on page 200. First off, we want to just remind ourselves that the Earth is a magnetic object. It has a north pole and it has a south pole, and the magnetic field lines run from the North Pole all the way down to the South Pole around the outside of the object. So I'm going to fill that in. Runs from the North Pole around the outside of the magnet to the South Pole. Again, from the North Pole around the outside of the magnet towards the South Pole. We also have two norths and two souths to speak about. We have true north, which is shown on geographical maps. We also have magnetic north, which is where compasses point towards. Likewise, true north on the exact opposite of the globe is true south, and on the exact opposite of magnetic north, we have magnetic south. So this is where compasses point. Okay, magnetic south and magnetic north is where a compass points, which means that a compass is a magnet. It aligns itself on the magnetic field lines of the Earth. Remember, the magnetic field around Earth is also 3D, so it comes out of the page towards you and in towards the magnetic south, likewise with these magnetic field lines. So, if we're looking at a compass, we know that north and south are attracted towards each other, which means that if this is the magnetic north, the south end of the battery of the magnet would be attracted. So blue is the south end of the magnet, which means that it is attracted. So this is the south end of the magnet that would be attracted towards the north if left to roam freely. That also means that the opposite end of the magnet is north. That leaves room for confusion. We know that a compass is always labeled pointing north. It has an N pointing towards north, which means that the compass, although it has been labeled north, it is in fact the south end of the magnet that is pointing towards magnetic north. It also means that the north end of the actual magnet that is rotating freely on a pin is pointing towards the south end. Please do not confuse the north end, the end of the magnet that is pointing towards north, to be the north end of the actual magnet. It is labeled north because it is pointing us towards north, but looking at the actual pin or actual piece of magnet within the compass, it is the south end of the magnet that points towards the magnetic north. Something to remember is that this compass will align itself with the Earth's magnetic field as long as it is not in proximity to another strong magnet. If a compass is brought in proximity, as in very close to another strong magnet, that south end of that magnet, which is labeled north, will rotate and start pointing towards the north end of the strong magnet that it is close to. So remember, if you want to truly be able to see which direction magnetic north is in, you would have to make sure that there are no other strong magnets in the near vicinity or nearby to that magnetic compass that you are using. Something else to remember is that the angle between true north and magnetic north is called the angle of declination. That angle over there, you can see, is 11.5 degrees.